Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. The link to this video channel with practice problems is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for today for exam P on probability. Let x0, x1 through xn be independent random variables and going into infinity. So be independent random variables all with uniform distribution on the interval 0, 1. Let n be the index of the first of the variables x1 through xn and so on, which is greater than x0. So n is the smallest of k such that xk is greater than x0. Find the expected value of xn minus x0. And here's the solution. Let us consider possible values of n. Given that x0 is equal to a specific value of x sub 0, we have n equals 1 with probability 1 minus x0 because the probability that x1 is more than x0. Given that x0 is 1 minus x0 as x1 is uniform on 0, 1, and x1 and x0 are independent. Then n is equal to 2 with probability that x1 is less than or equal to x0 and x2 is greater than x0, given that x0 is equal to x0. Well, x1 and x2 are independent, so we can multiply the two probabilities. So it's a probability that x1 is less than or equal to x0, given that x0 is x0, times probability that x2 is greater than x0, given that x0 is equal to x0. And being less than or equal to x0 happens with probability x0, and being more than it happens with probability 1 minus x0 because of the uniform distribution on 0, 1. And similarly, n is equal to 3 with probability expressed again as a product of three probabilities. x1 is less than or equal to x0, given that x0 is x0. x2 is less than or equal to x0, given that x0 is x0. And x3 is greater because we want to stop basically at 3. And we stop when we exceed the value of x0. And that's equal to x0 squared times 1 minus x0. And continuing this reasoning, we conclude that n is equal to k with probability x0 to the k minus 1 times 1 minus x0 for any positive integer k. Now let us first consider the conditional expected value, e of xn, given that x0 is equal to x0. So that's equal to the sum from k equal 1 to plus infinity of probabilities that n is k times the expected value of xn, given that x0 is x0 and n is equal to k. And once the value of n and x0 is established, xn is distributed uniformly on x0 to x1 because the value of x0 is x1. And, of course, xn is supposed to be bigger than x0. So this is the sum from k equal 1 to plus infinity of x0 to the k minus 1 times 1 minus x0 times that expected value that we see there, which is 1 plus x0 over 2, because it's the mean of uniform distribution on x0 to 1. That's equal to 1 minus x0 times 1 plus x0 over 2 times the sum from k equal 1 to plus infinity of x0 to k minus 1. That's a geometric series with a quotient of x0. Its first term is x0 to the 0, so it's 1. So its sum is 1 over 1 minus x0. So this is what we get. 1 minus x0 times 1 plus x0 over 2 times 1 over 1 minus x0. And so that's equal to 1 plus x0 over 2. And this implies that e of xn, which is expected value, of the expected value of xn given x0 is the expected value of 1 plus x0 over 2, which is 1 plus expected value of x0 over 2. So what's the expected value of x0? It's uniform 1, 0, 1. The expected value is 1/2, so that's 1 plus 1/2 over 2, and that's 3/4. And then the question is, what is e of xn minus x0? Well, that's expected value of xn minus expected value of x0, so 3/4 minus 1/2, and that's equal to 1/4, which is answer D. This problem comes from an old Polish actuarial examination, the Polish version of it. The copyright belongs to the Polish Financial Supervision Authority, which is called Komisja Nadzoru Finansowego in Polish. The solution that you see is mine, and all rights reserved for the problem to Komisja Nadzoru Finansowego, for a solution to me. A reproduction in whole or in part without express written permission from the author is strictly prohibited. Good luck in your studies and good luck on